All right, so we're gonna have this video here on exponential situations, and that way you can kind of work through it at your own pace and pause the video. And it's just hard for me to gauge how fast you're working. So I know some of you wanted to move a little faster, so here we go. Exponential functions can be used to model a variety of real-world situations. We will learn to model situations that involve exponential growth, increasing functions like population and compound interest, and exponential decay, decreasing functions like depreciation and radioactive decay. So the first situation is just bacteria growth. So there are currently 6 bacteria in a culture. The number of bacteria present triples every day. So we're going to complete the table by just multiplying by 3 each time. So you can go ahead and fill in the table. So we know 6 times 3 would be 18, and then 54, 162, 486, and 1458. So using technology, view a scatter plot of this data and find a regression equation. And so you can go ahead and do that part. Remember, it is under the stat key, edit. And some people were asking, so if you have a bunch of data already in your list, let's just make up some data. If I want to clear out that data, I'm going to arrow all the way up to the top of list 1. I'm going to hit the clear key. So I'm going to hit clear, and then I'm also going to hit enter. So clear enter will get rid of all of that for you. All right, so type in your X values, your Y values. We are going to do an exponential regression. So maybe I do want to show you how to do this. 1, 2, 3, 4, 5, 6. And our data was 6, 18, 54, 162, 486, 14, 58. That's it, right? So remember, to view a scatter plot, you go up to your y equals, so second stat plot. You're going to have to turn that on. Mine is already turned on, but you just hit enter on. And then if you hit zoom 9, it will give you your scatter plot. So here's my scatter plot. This is just another function that I must have in my y equals menu. I'm going to get rid of that. So exponential growth is here. So to do a regression equation, you go to stat. We want to calculate something, and you have to find it in this list, and it's all the way down at the bottom at 0, exponential regression. And it would be easiest to store my regression equation in the y equals menu. So that's under vars, y vars, function, y1, calculate. So my equation is y equals 2 times 3 raised to the x power. And it says, what do you think the parts of the equation you found in this represent? Times 3 is the tripling. Now, you might not see this, but if we go back to, say, day 0, 6 divided by 3 is 2. So the 2 actually represents kind of our starting value, kind of represents our y-intercept, right? Just like in a linear function, the y-intercept. But so that's where it's coming from. So you can't actually see the 2 in the table here. How many bacteria will be present on day 10? We're going to plug in 10 for x. And how many days will it take to reach 1 million? So we're going to plug in day 10 for x, and 1 million we want to get to as our y value. If you want to use your table, you can go to second table setup and you can jump to 10. I like to count by 1. So second table setup, start at 10, count by 1, and then go to second table. So actually, day 10, there are 118,000 bacteria, 118,098. So now we have to go down until we get to 1,000,000. And actually we get to 1,000,000 very quickly because 300,000 tripled ends up getting over 1,000,000. So by, this is days, right? By day 12, and if you don't recognize that E6 number, that means times 10 to the 6th power. It's scientific notation. So this is really 1, move that decimal 6 places. So 12, day 12. So that's the first exponential situation, bacteria growth. What about doubling pennies? So what if I told you I'll pay you 1 penny on day 1, then 2 more pennies, then 4 pennies, and I'll continue doing this for 30 days. Would you take me up on my offer? Would you help me move? Would you help me buy a car? So think about how many pennies are going to be given to you on the 30th day alone. So you could make a table. Our shortcut might be, how many times do we have to multiply by 2? 1 penny on the first day. So we have to multiply by 2 29 more times. So 1 penny, we're going to multiply by 2 29 times to get to the 30th day. And that's how many pennies we would have on the 30th day. Well, you want to take a look at how big that number is? 1 times 2 to the 29th power. Does everyone know how to do exponential? So it's that little upside down V shape under the word clear. That's how I got my exponent. It is that many pennies. And so if I divided that number by 100, I would have how many dollars? So how many dollars is that? $5 million? I'm giving you $5 million on the 30th day. And then I divided by 100. So $5,368,709.12 on the 30th day alone. So think about adding up all the previous days. Boy, if someone offered to pay you in pennies, I hope you would take them up on your answer. All right, here is another problem with when you're growing, interest. So what if you put $1,000 into a stock and it earns 7% interest each year? How much would there be in the account after 1 year? Here are 2 ways that you could calculate this situation. So first, you could take $1,000, multiply by the interest rate. So 7% as a decimal is represented 0.07. So I take 1,000 times 0.07 and I get $70 of interest. Now I add that to my original amount. So now I have $1,070 in the account. But I'm not just adding $70 each year. I'm getting interest on my interest. So now I'm going to have to take 1,070, multiply by 0.07, and then add back my original amount again. That's a couple steps. How am I going to do it when I go 20 times, right? So here's like the shortcut. So take 1,000 and multiply by 1.07. It's kind of like the distributive property. The 0.07 gives you the interest. The 1 gives you your initial $1,000 back. So voila, we have $1,070 in one step. So actually, to get the amount in any year, we can say $1,000 and multiply by 1.07 to the number of years right there for X. So if I want to get this spot, I'm going to plug in 2. If I want to get this position, I'm going to plug in 3, then 5, then 10, and then 20. And an easier way to do this is to plug it into your y equals menu. So we're going to plug in 1,000 times 1.07 raised to the x. We're going to go second table setup. Let's go back to year 1. Count by 1, second table. So then you can scroll through your table. See, there's 1070. Year 2 is 1144.90. 1144.90. So you can scroll through year 3, year 5, year 10, year 20, and answer the rest of that table. All right, situation number 4, another exponential situation. So what if this time you're standing 20 feet from the door to leave the room? Let's say maybe you're in detention. The teacher says that you can move half the distance to the door every 30 seconds. How long until you can leave the room? I want you to think about that situation. Think about how many times you'd have to cut 20 in half, add up all your 30 seconds. Will you ever be able to leave the room? Half of 20 is 10. Half of 10 is 5. Cut that in half again. Cut that in half again. I mean, eventually you're going to be so close to the door, it's like you're out the door. So give me a reasonable amount of time when you're going to be leaving the room. Technically never, but when it gets so close to 0, tell me how long. So you're going to finish filling in this table. You're going to write me a conclusion for situation 4. What about single elimination tournaments? March Madness is one of them. The NCAA holds an annual basketball tournament. I don't know what that's going to look like this year. They already canceled it for this year. The top teams are invited to play each spring, and when a team loses, it's out. So if you're in round 1, right, there's 64 teams in round 1. In round 2, there are 32 teams. Then there's only 16, right? 16 play in the Sweet 16, and then the Elite 8, the Final 4, and the finals. So I don't need to go to round 7. If there's only 2 teams that are playing in round 6, that's going to determine the winner right there. So how many rounds will there be? There'll be 6 rounds in this tournament because the winner will be decided during round 6. We'll be down to 1 team. We don't have to play round 7 with 1 team. All right, so what about if I had 128 tennis players? It's also single elimination. How many rounds would I need? I would just need 1 additional round, right? Because I'd go from 128 to 64, and then this took 6 rounds. So just 1 additional round. Okay. What about bouncing a ball? So when you bounce a ball, this is an exponential situation. So it says, most athletes and officials consider a true bounce important in the world of sports. Baseball players are often dismayed when a baseball takes a bad hop. Basketball officials commonly drop a game ball from chest height to see what its return height will be. Do you remember the, what was it called? Inflate, when the Patriots had footballs that were underinflated or overinflated? I forget. If the ball bounces well above the waist, it's too bouncy. And if the ball bounces below the waist, it's too flat. Similarly, a tennis or ping pong ball or player must react to the bounce of a ball, and these athletes cannot afford to play games with unpredictable bounces. Here's just some data that was collected. This was a tennis ball. They bounced it sometimes. Here's a basketball, tennis ball, basketball. Notice they dropped them from different heights. So it's hard to compare. This is not like comparing apples to apples. So the rebound ratio is found by dividing your bounce height by your original height. That will be able to compare apples to apples. Starting at different heights, I can't compare this data. So for the tennis ball, if I go through and I take 44 and divide by 80, the rebound ratio there was 0.55. Just for interest's sake, what if I do the next bounce? So what if I do 24 divided by 44? Oh, I get 0.55 again, about, right, rounded. What if I do 13 divided by 24? I get 0.54, it's pretty close. And then what if I do 8 divided by 13? 0.62, that one was a little bit off. So how am I going to find my average? This was just someone dropping the ball and measuring it, right? How do I find the average of 4 numbers? So if I wanted to find the overall rebound ratio, maybe 0.55 is the right answer, but let's just see what the average is. We add them up and divide by how many we have? 5, 5, 5, 5, 5, 4, and 6, 2. Divide that by 4. 0.57 is the average rebound ratio based on those 4 bounces of data. I'd like you to do the same for the basketball. So find your rebound ratio each time for the basketball and write your basketball rebound ratio average here. And if I continue, estimate the return height of each ball after the 5th bounce. So the 4th bounce was at 8. So I'm going to take 8 and multiply by 0.57 to get my final bounce. So 8 times 0.57. So I got 4.56 inches. You're going to take 16 and multiply by whatever you get as your rebound ratio for the basketball. So I haven't done the basketball yet. That's your job. Whichever one has the highest ratio is going to be the bouncier of the 2 types of balls. So tennis ball or basketball, which is bouncier? And it says what types of balls are going to have large rebound ratios. So they're going to bounce really high. And what other types of balls will have smaller rebound ratios? Maybe a bowling ball. Think of some examples of balls that aren't meant to bounce in sports. So you can finish up these couple questions on situation 6 by yourself. And this last page is kind of a cool trial, and we're not going to use real dice. We're going to use Dice Simulator on the computer. I'll show you where that is. So it says radioactive materials decay over time. This is because a certain percent of materials lose their radioactivity. When materials are plentiful and decay slowly, the materials pose a threat to humans and other animal populations. When the materials are scarce and they decay rapidly, then they pose only a brief threat to safety. So if you think about like when Chernobyl, the nuclear reactor spilled, that radioactivity is still present in that area. And that's why nuclear waste is so dangerous, because if we have a spill, that radioactivity is going to be here on Earth in our groundwater, causing problems for us with cancer for a long time. So we need to dispose of our wastes safely. Dice are going to be used in this situation, and the dice are going to represent Kennet 318, just going to be a pretend radioactive material, and it loses radioactivity over time. You will use dice to determine trends and predict future amounts. So you're all going to have a different set of data here. You're all going to do this activity. I'm just going to show you how I'm going to do it. So we're going to use, I'm just going to search on here, see if I can show you. Oh, wait. Oh, hold on one second. I'm going to get it to come up first. So I'm just going to go to Google because I can't see you and my camera is broken. Hold on. Let's see. I'm taking my camera off. Okay. All right, so you can see my computer screen if I hold it about there. So now I'm going to go over here. I'm going to search for Dice Simulator here. There's also a way to, so I'm just going to go this one, dicerollerrandom.org. I think you can maybe see that. I'm not sure. All right, so then I'm going to tell it to roll 12 dice to start with. I'm hoping you can see this. So I select to roll 12 dice. I'm going to roll the dice, and it's going to tell me what I just got. I want to remove all of the 6s because that represents radioactive material that's been lost. How many 6s did I happen to get? I got 1, 2 6s. So on my paper, if I got 2 6s, how many is going to be remaining? Only 10 dice. I just got rid of the 2 6s. So on my dice simulator, if I go back up here again, sorry, it's hard to show you. If I go back up here, I'm going to go to roll again. Oops, I'm going to go back. I'm going to now change it to 10 virtual dice. So now I'm rolling my 10 dice, and I'm going to count up how many 6s I get. Those are now gone. So your data is going to be different than someone else's data. The other thing I want you to do, we are going to end up doing an exponential regression on this. So you're going to put your data in your calculator. It's really important when you put the data in your calculator. Let's say, for example, when I get to roll 14, I have 0 dice left. So let's just say I had 3 here, 1 here, and 0 dice left. You might have 0 dice left over here. Wherever it is, do not include from there down. So don't include 0. Include all of the points that come before, but don't include 0 because exponential functions never reach 0. It's an asymptote. We'll learn about that, but it'll screw up your regression. So go until you're out of dice. If you have to keep going, just stop at 21. So like if you still have 3 dice left and you're at 21, just enter the data up through day 21 that you just still have 3. Don't enter 0. So wherever you get to, just go up to that point. So you're going to do an exponential regression, find the equation that fits your data. So let's just say, for instance, I'm going to show you my example data. So let's just say, okay, so I just made up my own data so I could pretend that I'm going to do this example because I want to explain to you what this stuff means over here. So you're going to take the data that you get. I'm not going to include 10 in my equation. So I'm going to put that data into the calculator. Okay, so let's just pretend this is my data, but you're going to have your own data in here and you're going to view your scatter plot. So you already have the scatter plot on. So I'm going to go to Zoom 9. Oh, maybe I don't have my scatter plot. Hold on. Second stat plot. I turned it off. Why did I do that? On Zoom 9. So there's my scatter plot. I'd like you to do an exponential regression, even though my data looks a little funky right here. I'd still like you to do exponential regression. So go to stat, calculate exponential regression. I'm not going to store it. I'm just going to calculate it. So 16 times 0.72 to the x is my equation. So that is my equation. You're going to write down your equation. I just want to explain to you what your equation is telling you. 0.72 to the x. Based on your equation, how much percent each time is lost and how much percent each time remains? This 0.72 represents 72% of your dice remained each time. When I went from 12 to 10, 10 to 8, 8 to 5 or 7. So I was retaining 72% of my dice and I was losing, therefore, 28% of my dice every time, right? Because 28 plus 72 is adding up to 100. So whatever percent you get here, I'm just interested to see what percent you get because we all have different experimental trials. So it would just be interesting to see who gets the closest to real life. So question 5, I want to do together, determine the theoretical probability. So this is experimental. You're going to have your experimental data here. Don't use mine. Determine the theoretical probability of rolling a 6 on one die. Isn't that a 1 out of 6 chance? So it says use the probability of rolling a 6 to estimate the percent you should lose each day. Don't I have a 1/6 chance of losing my dice, right? And I have a 5/6 chance on all the dice of keeping them. So what is 5/6? So that's 0.83. So in a real world, I started with 12 dice and I kept 0.83% every time. So this would have been our theoretical. So look, my equation was off a little bit. I'd be interested to see if yours is closer to the theoretical. The percent that is lost and the percent that remains. If I have 83% remaining, then I'm only supposed to be losing about 17% of my dice each time. So I actually had kind of a higher percent loss just by chance, right? By being random. So I'd like you to finish the dice simulator And then you are going to, you can just submit the back 2 pages, so situation 6 and situation 7, so that I know that you completed 005. And then you are going to move on and complete 006 on your own. And that should be some practice of those exponential situations. So you're going to also put 006 on Google Classroom. And then if you haven't had a chance yet, I'd really like you to try those Kahoot practice problems to refresh some of those linear skills. There were 2 posted yesterday and there's 2 posted today. So doing those Kahoots will help you improve some of your math skills, and let me know if you have any questions.